Welcome, my name is Terry Soul, and this is Programming Chaos, a channel devoted to fun and interesting programming projects to help you hone your programming skills. For today's project, we're going to be programming a procedural map generation algorithm based on the min conflicts algorithm, but also deriving the rules from a reference image. And so this particular approach combines two nice features. We can roughly sketch in the characteristics of the map that we want, oceans and mountain ranges and so forth. And then we can apply the procedural generation algorithm based on a reference image to fill in the details and make sure that the map follows the rules defined by that image. Okay, so there are two major parts to this algorithm. The first is the minimum conflicts, which takes a map that has lots of conflicts in it and tries to minimize those by identifying cells that have conflicts with their neighbors, so that violate the rules defined by our reference image. And by iterating multiple times, it eventually gets rid of all or at least most of those conflicts so that we have a map that matches our rules. And then the other piece of the algorithm we need is some way of generating the rules from our reference image. And that gets a little trickier, not so much generating the rules as how we are going to store the rules. So that becomes the question. In this case, because we're looking at terrains based on colors, we're going to have rules like hills can only be next to mountains. But a more complicated rule might be, well, grass can be next to grass or next to shallow water or next to forest. And so we have a whole set of options of what can be next to a given terrain, and it could also be in different directions. So we want to keep track of the directions in our rules. So let's take a look at how we might store those rules. So from a reference image, like this image here, we need to generate and store the rules. And the rules relate to, for a given cell type, or in this case, because we're dealing with maps, a given terrain type, what terrains are allowed to be on each side of it in each of the 8 different directions. And so, for example, if we look at terrain type 2, which I'm thinking of as grassland, you can have grass to the left or the right. But if we look at this cell, I'm allowed to have water to the left. And if I look at this cell, I'm allowed to have water to the right. And if I look here, I'm also allowed to have water above and diagonally and so forth. And so what we really need to know is, for a given cell type like 2, what is a list of all of the different cell types that can be in each of the 8 directions. And it turns out, and this is pretty typical for maps, this is a symmetrical image. And so for grassland, I can have either cell type 1, which I'm thinking of as shallow water, or other grassland, or cell type 3, which is hills, in any of the 8 directions. So I end up with a symmetric mapping just because of my reference image. And again, different reference images, this may or may not be symmetric. So that's the general idea. For a given terrain, what can be in all the different directions? Then we have to decide on a data structure to store that. And the one that I find simplest is a 2-dimensional array of array lists. So let's take a look at that. The idea is my 2-dimensional array has all of the terrain values versus all of the directions. And then for each terrain value and direction, it stores an array list of the allowed terrain types. So this is telling me that for terrain value 0, I'm thinking of it as deep water, the upper left of that can either be deep water or shallow water. And for terrain type 0, again, deep water, directly above it, we could, for example, only have deep water. And then, as we saw before, for grassland, to the upper left, we could have any of 3 different types, and directly above it, any of 3 different types, and so forth. So we create a 2-dimensional array with the terrains and the directions, and then each cell in that array is actually a list of all of the allowed values. So that's going to be our basic data structure for storing our rules. And then in addition to that, we're going to need a 2-dimensional array that represents the map, and it'll actually be an array of cell object. So I'm going to create a little object to represent each terrain cell. And then once we have all of that set up, we can apply the min conflicts algorithm, which will take a randomly generated map or a map that we've drawn and apply these rules so that all of the allowed neighboring terrain types or cell colors are correctly applied. Okay, so with that in mind, let's start the programming. For the programming, I'm going to be using the processing environment and programming it in Java. You can download processing from processing.org if you want to follow along. So for processing programs, we generally need two starting functions. The first one is setup. And that does exactly what you'd expect. It's run once to set up the program. And for now, all I want to do is create a window that's 800 by 1000 pixels. And then the other function you generally have in processing programs is the draw loop. And that loops indefinitely, updating the drawing window. Now, as I said, I'm going to start by creating a cell type, which will be used to store the information about the cells in my map. So let's do a new tab and call this cell. And I want to create a cell class. And each cell needs to know three things: its row, its column, and the terrain that it's storing. It'll turn out, as we sort of move ahead with the code, having the cells know their own row and column makes it a little easier for them to check their neighbors when we're doing the min conflicts algorithm. And then I should create a constructor for my cell, where we tell it which row and column it is, and we'll give it a random terrain. And I haven't defined the number of terrains yet. That's basically going to be a global that keeps track of how many terrain types I have in my map. And a little bit later, we'll need to add a display function so that cells can draw themselves on the screen, but I won't worry about that for now. What I want to do instead is go and start to set up the map parts of the code. So I need to know how big I want my cells to be. I'll make them fairly small, but you can modify that if you want. And then I need to know how wide and how high the world is. And that's simply the dimensions of the two-dimensional array that stores my map. And then the map itself is going to be a two-dimensional array, but of cells. So let's call this my world. Moving ahead a little bit, we're going to need to know the number of different terrain types. So I will have, for this example, 6 different terrain types, and that's my deep water and shallow water and grassland and forest and hills and mountains. And you can sort of see them all here in my map, but of course that you can change however you want. And then I'm going to need to store my rules. So as we saw earlier, my rules are going to be a two-dimensional array. One dimension is the terrains, the other is the directions, and inside each cell of that array is an array list that is just a list of integers, the neighboring cell types. And I see I forgot to put in my type for my cell size. Of course, that should just be an integer. And now I can go in and start creating my world map. First, I need the world width, which is simply the size of the window divided by the cell size. And then the same thing for the world height. But in this case, I'm going to leave a little gap at the bottom to put in some text. So you'll notice that down here, I've left a gap so that I can keep track of the number of iterations that min conflicts is going through and the number of resulting conflicts. That's not necessary, but it can be helpful for debugging the code and understanding how it works. So I'm going to go ahead and put that in. And so I've left that little gap at the bottom. And now I can create the world itself. So the world, of course, is just a new two-dimensional array of cells. The one thing that to be a little bit careful here is arrays are stored as the first value is the row, which is actually the height. So it always looks a little weird to me to put the height first, because I'm used to thinking of Cartesian coordinates where the x value goes first. When we're dealing with arrays, the row, which corresponds to the height, goes first. And then what I need to do is fill in the map. So we're going through each row and each column in the world and assigning it a new cell. And when we created the cell class, we have to tell it which row and column it's in so it can keep track of that. And just to double check, always a good idea, this I'm putting in as row followed by column. And in the cells, yes, it's receiving it. It's taking those arguments as row column. Always nice to make sure that those things are correct. Okay, so that creates our map. And it fills it in with random terrains because when I create a new cell, that new cell is assigned a random terrain out of the number of terrains. So now we can go ahead and actually draw that. So let's come down here, give myself a little more space. So what I want to do is go through, again, each row and each column and ask that cell to display itself. And I'm getting an error message because I haven't written the display function yet. And I'd actually like to do this not using RGB, but using hue, saturation, and brightness as my color parameters because I'm a little more comfortable with that. So in processing, I just switch the color mode. Color mode. There we go. So hue, saturation, and brightness, the hue is 360, which basically gives me a color wheel. And then the amount of saturation and brightness, I'll just do is 0 to 100. So now what I need to do is come in and write my display function. And I need to pick the right color based on the terrain type, which I'm just going to make a long switch statement. Bear with me. So case 0, which I'm thinking of as deep water, I'm going to give it the hue of 210, which is a dark blue, maximum saturation, but not too much brightness. So I'll get a dark blue there. And then I just need to do the same thing with the other terrain types. There's my light water. There's my grass. This is going to be forest. So we see that on the map here is the dark green. That's a grayish color, which is going to be hills. This ends up being white. So 0 degrees is actually red, but I'm using 0 saturation. So there's no red to it, but there is maximum brightness. So that will give me white, and that'll be sort of my high snowy mountains. And then hopefully I won't need it if I did everything right, but it doesn't hurt to put in a default in case you have a terrain type that isn't listed somehow, some error in the code. And I will fill in my default with bright red. So if bright red shows up anywhere in the terrain, I know that I have some error here and didn't find the right terrain type. Finally, the last thing we need to do is actually draw in the cell. So that's just going to be a rectangle. And we'll draw it at whatever column we're in times the cell size. And in this case, the column comes first because that's the X value. And then the row times the cell size. And it's simply a square that is cell size by cell size. And it occurs to me when we come back here, in addition to setting the color mode, I want to use a no stroke command so I don't get lines around the outside of my cells. And you may or may not want strokes. We can take a look at how it looks with and without them. But there we go. This is a totally randomized map. So I've got all of my terrain types just filled in randomly with a little gap at the bottom here so that I can put in some text later if I want to. Clearly not much of a map because we haven't done anything with it yet. Now we need to start figuring out what the rules should be based on our reference image. I'm going to add another function to generate the rules for me. And the idea here is I'm going to go through each cell in my reference image, which I have not included yet, but I will in a minute, each cell in the reference image, look at the terrain type, look all around it, and keep a list of all of the terrains that I see around that cell. And in order to do this a little more flexibly, I'm going to pass in the reference image as a parameter. So my reference image, I keep referring to it as image, is really just a two-dimensional array of integers. And so let's go ahead and create a reference image so you sort of know what I'm talking about here. And I'll do this again using a new tab, and this will be my references. We can have more than one, right? Because the whole point is to generate the rules from the reference. So here's the idea. As I said, rather than an actual image, I'm using a two-dimensional array of integers, and they tell me which type can be in each cell relative to the neighboring cells. And so maybe make that a little clearer. I want to put in something like, well, a bunch of zeros across the top row. And if we look back here for just a minute, this is, for example, a reference image that I've been using. And so the top row is all zeros. And then the next row has a 0 followed by a bunch of 1s. A deep water followed by shallow water, and so forth. And so that's what I want to create. However, I don't want to take the time to type it all out because nobody wants to watch me do that. So I'm just going to cut and paste it in. There we go. And so, as I said, a bunch of zeros across the top, which is sort of my deep water. And then inside of that, a row of shallow water, and inside of that, a row of grassland. And this is a fairly simple reference image to be using. You can make any one you want, and it will automatically generate the rules for what types of terrains can be next to each other in any direction, just based on this image or this array. Okay, so I've got the reference terrain that I want to work from. I'm actually going to pass it in as an argument, and then I can start generating my rules. So here's the first thing that I do. I want to go through every cell in that reference, again, image. So I'll go through each row, and the number of rows is the length of the array. And then I need to go through each column. And the columns are the length of one row. So I'm just taking the 0th row, and the length of that row is the number of columns. And now what I need to do is get the terrain at that cell. So the terrain I'm interested in is just in the reference, that row and column. And then I need to go around the 8 directions. And this may look a little weird. What is the use of going from 0 to 8? How does that get me around the 8 directions? Well, I'm going to put in a little trick here. What I want is the new row, which is going to be equal to the old row plus the delta row of the direction that I'm currently looking in. So I have a new row value, which is equal to the old row plus some delta row. And so I have to create this array. The idea is the delta row tells me for each of my 8 directions how the row should change. To use a more concrete example, if I'm interested in a particular cell and the first direction is, for example, upper left, then the row gets smaller. So that's a -1. And similarly, I need to know my new column, which is going to be the old column plus the change in column. And if I'm looking to the upper left, the change in column is also -1. So basically my 0 direction is the -1, -1 direction to take me to the upper left. And then my 1 direction for me will just be straight up. So that's -1 for the row and 0 for the column, because I'm in the same column, but I've moved up 1. And basically, we're putting in the change in the row and the change in the column for each of these 8 directions. And there's other ways to handle it, but I find this one a pretty useful way to think about it. So first, if we think about the rows, my first 3 values are above the cell, so that's -1 row. my next three values are in the same row as the cell, except that I'm skipping over the cell itself. So there's actually only the one to the left and then the one to the right. And then my third three values are one row down. So +1. And that should be a curly bracket. There we go. And then if we think about the columns, the first column is to the left, so that's a -1. The next cell is in the same column. As I said, that's a 0. The third column, or the third direction, is one column over, so that's a +1. We move to the next row. We want to look at the cell to the left, a -1, and a cell to the right, a +1. And then we get one row down. And when we're one row down, we want to look to the left, directly below, and to the right. So those deltas will look all around my current cell in the 8 directions. Now I need to make sure that my new row and new column are actually in my reference image, because I don't accidentally want an overflow error here. So make sure that my new row is larger than 0 and less than the number of rows in my reference image. And I'll just put this on a new line, keep it a little more compact. My new column has to be larger than or equal to 0, and the new column has to be less than the length of one of my rows. So I'll just use the 0 row, same as I did up here. And as long as that's okay, what I want to do is take my rules for this particular terrain and this particular direction. So I know the terrain of the cell and I know the direction D that I'm looking at. And I want to take those rules and add to it whatever terrain I find in that new location. So basically, if the terrain value is 2 and I'm looking in the 0 direction, which is up and to the left, I want to add to my rules for 2 and to the upper left whatever terrain type I find to the upper left. And that's actually all it takes for generating my rule set. And let's see what my error is here. Oh, I does not exist, because that should be, as you probably noticed, the direction. So this will generate all of my rules for me. And I also notice, you probably caught this already, that that should be the delta column. So this generates that two-dimensional array of rules that I was talking about. By itself, it's not very useful. What I have to do next is the min conflicts algorithm to actually apply these. Before I start the min conflict code, I'd better actually call this function. So let me quick copy it, and we'll make sure that we generate the rules using our reference terrain image. So now we can go ahead and start writing the min conflicts algorithm, and I'll put this in a new tab to keep things a little more organized. So the min conflicts is just going to be an algorithm that I call, and what it does is it goes through each cell in the map, looks to see if there are any conflicts, counts the number of conflicts, and if there are some, it then tries to change its own cell type into a new type, a new terrain, that ideally reduces the number of conflicts, although as we'll see, it might just change to a new type that keeps the number of conflicts the same. This is a stochastic optimization process, and so giving it a little flexibility there can be helpful. Now, there's a bit of code that we need to add before we get started, because we need to go through each cell in the map. But if we start at the upper left and move through it consecutively, we'll end up with some artificial biases in direction. We'd like to pick the cells randomly. And so what I want to do is take my list of cells and shuffle them, but I don't actually have a list of cells yet. So I'm going to go back to my main code and create that. So in addition to the world, I also want to create an array list of cells. So this array list is going to store all of my cells for me. And because it's an array list, I can shuffle it. And in order to use the shuffle function, I have to import for Java utilities the collections library. And most languages that you work with, if you're not working with Java, have some sort of a shuffle function, which is what I'll be using, which takes a list like an array list here and just shuffles the values around. I'm including the appropriate library, I'm defining the array list, and what I need to do is add each cell to that array list. So down here, when I create a new cell, I also want to put it into my array of all cells. And that will work better if I spell world correctly. So there's something a little tricky going on here. I have the world, which is a two-dimensional array of cells. And then I have my array list, which is an array list of all cells. But it turns out both of those are referring to the same set of cells. So in my world, there's a cell in the corner 0, 0. And in my all cells array list, that same cell is represented but somewhere else in the array list. And both of those things, the value in the array list and the value in the world two-dimensional array, actually refer to, I can't say point to because we don't have pointers in Java, but they both refer to the same cell object. But what this allows me to do now is to go into my min conflicts algorithm and take that all cells and shuffle it. And the syntax for that, which I always get wrong the first time, is to use the collections shuffle function and give it that array list of all cells. So this takes the list of all the cells and shuffles them around, and then I can go through them in order. In order to do a little bit of debugging here, I'm going to keep track of the total number of conflicts so I can see that it's going down over time, or at least ideally going down over time. And so I'll start with 0 total conflicts. Now I can go through my shuffled array list of cells and do the whole count the number of conflicts and see if different terrains will lower the number of conflicts. So first I need to go through all the cells. And then I need to count the number of conflicts. And my count conflicts function doesn't exist yet. I'll need to write it. But what I want to pass into it is the current cell that I'm interested in and the current terrain. And the reason why I'm passing in the terrain, which might seem a little weird, is because in order to check other terrains, I might want to pass in a little bit a different terrain. So this cell might currently have grassland, but I want to count the number of conflicts if this cell instead had, say, water in it. So this will make my count conflicts function more reusable. Doesn't exist yet, so I'll have to fix that here in a minute. But I can say if the number of conflicts is larger than 0, then I have some work to do. The first thing I can do is add to my total conflicts, because I know that I've just found one. So that, like I said, is going to keep track of the number of conflicts in the map for me. And then I need to check all of the neighboring terrains, and if they have fewer conflicts, or maybe even the same number of conflicts, I need to add them to a list of possible replacements. So what I need now is an array list to store my possible replacement terrains in. And actually, I'm going to go up here to put that in. There we go. So this is going to be my array list that I store the possible replacements that will go into this cell C that has some conflicts currently. And I need to clear that array list each time. So every time I find a new cell that has some conflicts in it, I want to clear the replacements and refill it in. So now I can do the following. For each possible terrain type, I want to count the number of conflicts for this cell if it was replaced with the new terrain type T, where T I'm going to loop through all possible terrains. And then I can say if the number of conflicts is less than the previous number of conflicts, so if this new terrain will give me fewer conflicts, then I want to add the new terrain type as a possible replacement. Let me walk through that real quickly. For every cell in a shuffled list, so I look at each cell in a random order, I look at how many conflicts are there. If there are 0, no problem. I'm actually going to just loop and look at the next cell. But if the number of conflicts is larger than 0, I'm going to remember that I've had one additional conflict. I'm going to clear the possible new terrain types, the possible replacement terrains. I'm going to go through every single terrain type there is. I'm going to count the number of conflicts with that new terrain type. And if the number of conflicts is less than my original number, then I'm going to add it to my options for replacements. Once I've gone through every terrain type, so I'm done with this for loop, all I want to do is put in one of those replacements. So I want to say the new terrain for this cell should be selected randomly from my array list of replacements. And this gets a little long, so I'm going to put it on a separate line. There we go. So from my replacements, I'm just picking a random new terrain. There are some options here that are worth mentioning. I am only accepting a new terrain if it has fewer conflicts. This is a pretty strict condition, and it can sometimes lead to the algorithm getting stuck with some remaining conflicts because there's no new terrain that lowers the number. So in some cases, you'll want to make this a less than or equal. And so it will say, well, I have 3 conflicts. Let me put in a different terrain that also creates 3 conflicts, but maybe that will break sort of a log jam. And in some cases, you might even want to go a little bit further and say, well, or with, for example, a 2% probability, I will make this an allowed replacement even if it doesn't lower the number of conflicts. So I'm actually going to replace a terrain with a different terrain that has more conflicts. This can be helpful, it turns out, if you've gotten to what's known as a local optima. So we have, for example, 2 conflicts. Any terrain change I make will still leave me with 3 or more conflicts. So I'm sort of stuck. But it may be that making a random change that actually does give me 3 or 4 conflicts will allow other terrains to change. And so probably not critical in this case, but depending on exactly what your reference image is and how strict it is about the rules, sometimes allowing a worst case will break you out of what's known as a local optima. Similarly, putting in the equals can be helpful. So depending on the map you're dealing with and the reference image you're dealing with, you may want to play with these conditions a little bit. So let's see, I need to close out some of this code. That is my if the number of conflicts were larger than 0, and that was for going through all of the cells. And you'll notice I'm now getting my error messages because count conflicts doesn't exist. Another thing that I want to do is go in and say, well, if my total conflicts are larger than 0, I'm going to increment the number of iterations. And let's see, I'm getting an error message there. Did I put that in at the beginning? No. Okay. So I want to keep track of how many iterations do I have to go through this. So let's put in on iterations equals 0. This will keep track of how many iterations do I have to go through before I've resolved the map so that there are no conflicts. So there, I'm going to start with 0 iterations, and every time I run through and have conflicts to resolve, I will increase that number. And then I'm going to put in a little extra code here to print some of that data for me as it shows up on the bottom of the screen down here, because I think it's useful to understand the algorithm. Let's get a little more space. So this is just some text output. Has nothing really to do with the algorithm other than keeping track of how it works. There we go. So I'm going to center align my text. I'm going to use a nice big text size. I'm going to fill in. I'm going to make my text 0, which is to say black. And then this just prints the word iteration equal, and then the number of iterations I've gone through so far, because it keeps upping it every time there is a conflict. And then it'll also print the current total number of conflicts for me. Again, none of it's necessary, but it is nice to track the algorithm. The thing that is still missing is my count conflicts function. So we need to put that in, and that will return the number of conflicts. And we pass it in a cell, and then we also pass it in the terrain in case we're trying to replace it with the current terrain with a new one. So I'll start with 0 conflicts, and then I just want to look in each of the 8 directions and see whether the terrain there violates my rules or not. So I'm looking in the 8 directions, and then I actually want to do exactly the same sort of code that I used before in terms of calculating a new row and a new column. But in this case, I want to wrap around my map. And that's up to you, but I want to think of my map as wrapping around. So when I check the bounds for the new row and the new column, I'm going to do it a little bit differently. There we go. So I'm going to take the old row location, which I know from the cell. Remember way back at the beginning, I said each cell knows its own row, and that will come in handy. And you were probably thinking, why would you bother doing that? This is why, because now I can figure out which row the cell is in. There are other approaches to this, of course. You could pass in the row as an argument instead, but I kind of like this approach. Then I'm going to add in the delta row based on the direction. And this is where things get a little interesting. I'm then going to add the whole world height. This is the row, so I'm adding the whole world height. And then I'm doing a mod of the world height. And that basically allows me to wrap in either direction. So this will give me a wrap result. And I'm getting an error message here because dr doesn't exist. I'm going to go back over to my original code, and I'm just going to cut and paste this because you don't want to see me type it again, and I don't want to have to type it again. So there's my delta rows and delta columns that I'm going to need. And then I can copy this over, but for columns. So that gives me the new row and the new column. And now I just want to check whether or not that's allowed in my rules. So I'm checking the rules for the terrain I'm interested in that I passed in and the direction I'm interested in. So remember that when we created our rules, it was a 2-dimensional array, terrain versus direction, and then inside was a list. So what I want to know is, does the rules contain the terrain at that new cell? So I'm asking for the cell that I'm located at, maybe it's grassland. The new cell, maybe it's to the upper left here. Do my rules allow the terrain in the upper left based on that grassland? And I'm using contains to check whether it's in the array list. Notice that what I'm really doing is asking if it's not in the array list. And if it's not in the array list, then what I want to do is increase my conflicts by 1. And the very last thing is simply to return that number of conflicts. So this tells me the new number of conflicts. And let's see, if I go back here to my code, what I am missing is actually calling that min conflicts algorithm. So let's draw the map and then call it and see if this works. Let's see, count conflicts does not exist. What did I do wrong? Oh, probably saw that. Should be count conflicts. I was missing a U. Okay, so the issue here is when I'm adding to my all cells, that's my array list of all of the cells in the map, I have defined it up here, but I forgot to actually create the empty array list. So we should do that. There we go. And in thinking about it, there's a couple of other places where I made the same mistake, and you probably already caught it while I was coding, but I want to correct it before I try and run this again. When I created my set of rules, I did not initialize this list. I just added it in. So I need my rules to be a new 2-dimensional array of array lists. So this makes sure that my set of rules is an array of the right size. And then I actually have to do one more thing here just to make life a little more complicated. This is a two-dimensional array. Each entry is an array list. I've got to make sure that each of those array lists have been initialized. So I need another bit of code in which I go through all of the terrains and all of the directions and make sure that my rules for that terrain and that direction actually has an empty array list that down here I can add to. General coding practice, which I was getting a little sloppy on there, define your array, but you need to make sure that you create it the right size, and for your array list, you need to make sure they exist. So now, let's see if this works. There we go, our whole map, and you can see it resolved very quickly into a collection of, we have mountains and hills and forest and grassland and water and some deep water. It went by very quickly, and I realized I never did update the background, so you just get a blur down here. So let's go in and on each draw loop, we'll clear the background. And there you go. You can see that it took 19 iterations before it reached a point with 0 conflicts. And so this is a map that follows all of the rules for what terrain types can be neighbors of each other based on this reference image. And if we want to sort of see it in action, we could go in and you can actually slow down the frame rate. So this will do 1 frame per second. There's our initial random, and you can see it slowly resolving those conflicts. It starts with a huge number of conflicts, of course, and getting smaller and smaller as it goes. And for example, in here, there's still some conflicts that it's trying to resolve. It's going up, took 22 iterations instead of 19. So the number of iterations will vary because this is a completely stochastic process. But there we go, there's our map with all of the conflicts resolved based on our reference image. The key to this is we started with lots of conflicts, which means it's perfectly okay for us to draw whatever map we want. And then the minimum conflicts will come in and resolve any conflicts that our drawing created based on the rules from the reference image. And so let's go ahead and put in some of those drawing capabilities. It'll take a couple minutes, but I think it's worth it for you to have them available. So this is going to be a very primitive little bit of drawing code so that you can sort of sketch out what you want for your terrain. And I highly encourage you to refine the code a bit to make it look nicer. So the first thing we need to know is whether we should be running the min conflicts algorithm or allowing the user to be drawing the terrain. So I'm going to put in a Boolean to determine that. And let's start with it as true. So I'm going to start, in a sense, in drawing mode. And then what I want to do is come down to my draw loop, and instead of calling the min conflicts every time, I'm going to check whether or not I'm drawing. So if I'm not drawing, then I can run the min conflicts algorithm. Else, I want to run my drawing function, which I haven't written yet, of course. So this is going to be the function that allows me to draw. And so I'm going to do yet again a new tab, and let's just call this extras, because this is not part of the min conflicts algorithm, but it makes the code a lot nicer because you can draw your own maps. My function is called drawing. So let's put in drawing here. And the basic idea is if the mouse is pressed and I'm in the drawing mode, then I want to change some of the cell terrains. So if drawing is true and the mouse is pressed, let's figure out which cell I'm looking at. So the row should be the Y position of the mouse divided by the cell size. Right, so take the Y position, divide it by the size of my cells, and make that an int, and that tells me what row I'm looking at. And then I can do the same thing for the column. One option would simply be to change the terrain in that particular cell, but that's going to be a huge pain when I have these very little cells. I'd actually like to change all of the cells in a particular radius. So let's put that in as well. So here's the idea. I'm starting from the row of the cell that I clicked on, and I want to go up some radius. Think of that as the radius of my paintbrush, if you will. And then I want to go all the way down to the cell that I clicked on plus the radius of my paintbrush. And I'll just iterate over all of those. And then I'll do the same thing for the columns. So this is basically going to take the cell I clicked on and look at a square around it. So radius is a little misleading, but I'll fix that by just calculating the distance. So let me show that. So here I'm calculating the distance from the cell I clicked on to the other cells I'm interested in. So the cell I clicked on, and then I have the square around it, and I'm calculating the distance to each of those. And as long as the distance is less than the radius, I can actually go ahead and change the terrain. So if d is less than the radius, and then I got to do some other checks because I don't accidentally want to draw off the edge of the screen. So if d is less than the radius and going to get a little long, the row is larger than or equal to 0, and the row is less than the world height, and I'll put this on a new line. The new column is larger than or equal to 0, and the new column is less than or equal to, excuse me, that should be strictly less than the world width. Then I can say the world cell at that location, R new, column new, should have a terrain value that's equal to whatever my draw value is. Well, let's close all of that out, and then we can go in and fix some of the things we're missing. So in particular, we're getting an error because radius doesn't exist, and also because the draw value doesn't exist. So I'm going to add some globals. Let's start with a radius of, say, 10 and a draw value of 0, which, by the way, happens to be deep ocean. And then I've also misspelled height. So now, at least to begin with, I'm always going to be drawing with a circle of radius 10, and I'm always going to be adding deep ocean. The one piece that's missing is right at the moment I start with drawing being true. So I'm going to start by drawing, but I don't have a way to switch back and forth between them. So one more bit of code we need. If we press a key, if the key is equal to, try that again. If the key is equal to a space, then I want to switch from drawing to not drawing mode. So pressing the space bar will switch modes. So if I run this, I get my random map, and I should now be in drawing mode. Let me stop this and comment out the frame rate because I don't want to deal with a frame rate of 1. There we go. So I'm in drawing mode. I can put in some ocean. I'm really not very good at designing maps. You can probably do a better job than me, but there we go. Maybe make some more continents, put a little inland sea in. And now I'll press the space bar and we'll switch to the min conflicts mode. And there we go. It has gone in and applied the rules to fix all of our continents. The issue, of course, is all I can draw is ocean. And in fact, if I press the space bar, I go back into drawing mode and I can add some more ocean and then resolve any resulting conflicts. If I want to make this a little fancier, what I need to do is be able to change the color that I'm dealing with. So let's go ahead and do that in my key pressed. A temporary value, which is equal to whatever key was pressed minus not 0, but the character 0. So the idea here is that if I press the 0 button, I'm actually getting an ASCII value. I'm subtracting the ASCII value of 0. So I have the ASCII value of 0 minus the ASCII value of 0, which gives me a 0. Or if I press the button 3, I have the ASCII value of 3 minus the ASCII value of 0, those are different by 3, so I'll actually get the number 3. And so now I'm getting the correct number, and I just have to double check that my temp is in the right range. If temp is larger than or equal to 0 and temp is less than the number of terrains, then it is okay to say that my draw value is equal to that temp. So now when I run this, I again can start by putting an ocean, draw around the edge here, divide this into a couple of different continents. But now if I press a key, for example, 5, that will give me mountains. So I can say, I want a mountain range in here. And maybe I want some mountains down here. And then I can press 0 to get deep water again and put an ocean inside my mountains, or put an inland sea over here. Or I can press 2, which is grasslands, and say, I want a bunch of grasslands here. And then if I want some islands, tends to work pretty well to start with mountainous ones and then let the min conflicts, there we go, sort of smooth them out. Clearly, one issue we're running into is I have a fixed brush size, if you will, so I can only put in huge regions of terrain. So if you want to refine this a little bit further, you could go in and add some more keys. So if I press minus, my radius gets smaller. If I press plus, my radius gets bigger. All sorts of things you can do. But based on the code we have so far, you can draw a rough map and let the min conflicts fill in any of the details. And we can switch back and forth and go in and say, let's make a little bit of an inland sea here, and then smooth it out so that we don't have any conflicts. And you'll notice each time it's updating the number of iterations until we get down to 0 conflicts. So what can you do with this? Well, all sorts of things. As I already mentioned, we can go in and put in a little code to adjust the brush size if you want. All of what we get is based on the reference image. So create a difference reference image and you can generate different kinds of terrain. But again, there's nothing that says this is limited just to terrain maps. Whatever the reference image is, that is the rules that will automatically get applied. So if you're familiar with, for example, wave function collapse, it works very similarly. It uses a reference image to generate the rules, and then it goes through and adjusts each cell so that it doesn't conflict with any of the rules. The same thing we're doing here. The big difference, and the reason why in some ways I prefer minimum conflicts, is with wave function collapse, you can't do the drawing because as soon as you put conflicts in, wave function collapse doesn't know how to deal with them. Min conflicts expects conflicts. That's the whole idea. We want to make some ridiculous map that totally breaks the rules where we have deep water and right next to that deep water we have mountains. Totally illegal based on our reference image. Min conflicts will go ahead and say, I just need to fill in with some grassland and hills and forest in between and everything is okay. So this allows you to draw the maps or other patterns that you want and then allow the min conflicts procedural generation to fix all of the errors that might be in there. I would love to see if you get this implemented and create some maps of your own or any other patterns. I'd love to see how they turn out. So feel free to add a comment down below. Thank you and happy coding.